Okay, hello and welcome back to another digital electronics video. Now last time we had a quick look at transistors, the AND gate, the OR gate and the inverter. We went through truth tables and a little bit of Boolean algebra. So today we're going to go straight into it and look at our next gate. It's called a NOR gate. Now you probably recognize that little symbol here. That is the OR gate, but the OR gate has a little bubble next to it. Okay, if we have a look at the OR gate, you can see how very similar it is. The only difference being that little circle. When there's a little circle after a logic gate, it means the output is inverted. So in Boolean algebra, and if we have a look at our truth table, okay, we can see here that y is equal to a or b inverted. So our OR gate, remember one or both are on, then the output will be on. The inverse of that would be when both are off, the output is on. And then when one or the other or both are on, the output is off. Very simply, that would be our circuit diagram. So you can see here we have an OR gate, which is our diodes, remember? Our diode OR. And then that goes into an inverter, which was our transistor hooked up to the output. So a very simple circuit. So what we're going to do is we're going to build this on the breadboard and see if that works as expected. We're going to build our OR gate, then we're just going to stick an inverter on the output and see how that goes. Okay, and here's our NOR gate, as you can see. So remember last time we built it with two inputs, two diodes. These are connected to 5 volts, so we input 5 volts into here. It will go through our output. Up here we've got our pull down resistor. So when one or both of these are on, then the output will be up or high. Now the thing with this is we've connected that to an inverter now. So when this is actually low, the inverter output will be on. And when this is on, the inverter output will be off. So what we're expecting is when we turn this on, neither of these buttons are pressed, and according to our truth table, our LED should come on. And then when we press one or both of the buttons, the LED will go off. So let's test that, turn it on, and bingo, we have success. Now if I press this button, the LED should go off. And it does. If we press this button, the LED should go off as well. And it does. And if we press both of them, the LED will go off. Marvelous. So as you can see from the computer simulation on the screen now, you can see exactly how the current travels through this circuit. So you can see when we press one button, which way the current will actually flow, causing the LED to go off, when we press the other button, and when we press both buttons. So it's quite a good little thing to watch for. Okay, so that's our NOR gate, the NOT OR. The last gate that I want to look at, for now at least, is the NAND gate. Now the NOR gate and the NAND gate are what's called universal gates. You can use those two to create any other normal gate. I'll explain about that in another video. But for now, let's have a look at the NAND gate. You probably recognize the symbol as an AND, and again with a little bubble on the end, that inverts the output. So that will be the NAND gate. Here's the truth table for that. So Y is equal to A and B inverted. So 0 and 0, or off means the output is on. On means the output is on. Off means the output is on. But when A and B are both on, the output is off. Marvelous. Now, this is actually a slightly easier gate to build. Don't need so many diodes and stuff. You can do it with just 2 transistors. There we go. Simple as that. So this would be our inputs here. So when they're both on, then the current just goes straight through to ground. But when one or both of them are off, it can bypass and go through to ground, causing our lovely little circuit to be here. Marvelous. So let's build that and see how that works. Okay, so here we go then. This is our NAND gate. As you can see here, I built it with 2 transistors. So looking at the diagram, let's have a little look at this. So the positive 5 volts is connected to the collector on the first one via a current limiting resistor, and our output is here, which will be our LED. This is connected straight away into the second transistor, so the emitter of the first transistor is connected to the collector of the second one, so we can see here. Our switches are connected by current limiting resistors to the base of each transistor, and each one of those is connected to 5 volts. When we press the button, 5 volts will go into the base. And finally, the emitter of the last one is connected to ground. Now, instead of doing this whole loop around, what I've done is I've connected the output here directly into ground, but with a LED in the way. So this would actually be our output here. Okay, let's power the circuit on. So we can see here, as soon as we turn it on, we get a 1, which is correct. So when both inputs are off, then we have a 1. Now, if I switch one switch on, we still get a 1 on the output. If I put the other one on, we still get a 1 on the output. If I press both of them, the current sinks down into ground and the light goes off. Just like that. Okay, so that's the NAND gate. Okay, and you can see there from the electronic simulation how this would actually work. So when one is on, you see where the current goes, and when both are on, you can see that that would actually take all the current away from the output and create an NAND gate. Okay, we do have 2 more gates to go through. We have the exclusive OR and the exclusive NOR gates, so the XOR and the XNOR. But for now, that's all I wanted to do. We'll also be moving on to TTL as well, transistor logic, and looking at things like the 7400 or the 74LS series of microchips. We're going to try and simulate one of those as well using transistors on a breadboard. So that's going to be fun. But thank you very much for watching this video. If you liked it and found it interesting, please hit the like button. If you didn't, please leave some feedback. Let me know what I can improve. And yeah, thank you very much. Like, comment, share, subscribe. And until the next time, until the next video, thank you very much for watching. Catch you later. Bye-bye.